Hello everyone, I'm CHIN from Taiwan. Here to give our presentation on behalf of our team, Metformin 121. We are going to introduce our work in the CODA TB DREAM challenge, and the title of the presentation today is a general end-to-end solution to predict patterns from different types of biomedical signals. And I'm going to briefly introduce our team members here. First, I'm the leader, just I mentioned, CHIN, and also the speaker today. I also awarded the Google PhD Fellow in Data Science degree program of National Taiwan University and Academia Sinica. And also our manager here is Huang Jihan, and a good member here, Chen Zhiyu, Dr. Edward Xuanchen, and Dr. Wang Xuankai, and Huang Guilin, and Dr. Chi Hao. Also, I'm going to introduce about our consultants, Dr. Chao Yu and Dr. Wu Zhixun. They are all good professor or research fellows in our team. And now I'm going to talk about the evolution of our solutions. In 2018, we developed the MetforNet v1.08, the first version of our network. And that time, we used the input as electrocardiography, and output is a cardiac arrhythmia classification. This model was designed for the competition held by the China Physiological Signal Challenge 2018. And then we won the first place of that and published a journal article in iScience. In 2022, MetforNet v1.0b, which is almost the same network architecture, but applied in different types of the output. That time we used the output as the mortality, and also the result was good to publish in JACC Asia of the journal article and win the Clinical Innovation Award of the 20th National Innovation Award. In 2022, we further improved our MetforNet into the MetforNet v2.0. This is the first time that this network could digest not only the signals but also the other clinical data. The results gave us the first place of the 2022 data science competition. And part of the research results was published in the IEEE Transactions on Consumer Electronics, which is a journal article. In 2023, we first applied our MetforNet into the CODA TB DREAM challenge. In this challenge, the input is the cough sound, and the output is tuberculosis classification. That is also the first time we use the MetforNet with the different types of the biomedical signals. Continuously, almost at the same time, another DREAM challenge was established. That's the time we try to use our MetforNet v1.0c to digest the DNA sequences and output the expression levels as a prediction. Continuously, we further improve our MetforNet into v2.5b, and we win the excellent prize of the 2023 AI Cup Multimodal Pathological Voice Classification Competition. So, this is the architecture of our MetforNet v2.5a. And this architecture is very simple, and basically it has two outputs. One is without clinical data, another is with clinical data. For the part without clinical data, we use the backbone architecture of our previous MetforNet v1.0a and utilizing the voice signals. But in this competition, we need to utilize the demographic and clinical data. So we designed a digesting network to utilize those information. So Those information was digested and concatenated into the attention layer of our backbone architectures. Going through the fully connected ADD layer, then we can have another output probability with clinical data. And this model is very simple. You can see the total parameter is just 28,826. So that means this model is very compact and can be applied to the edge computing devices. And this is the performance of our MetforNet v2.5a. As you can see, from the CODA TB DREAM challenge, sub-challenge 1 and sub-challenge 2, they correspond to the output probability without clinical data and with clinical data. So our model's performance could be easily evaluated by the leaderboard. You can see, using without the clinical data, our model ranked only in the 5th place. But when we utilize the clinical data, we won the 1st prize in the sub-challenge 2. So that means our model could utilize the clinical and the demographic data information very well. For the first information of our team, you could take the QR code below, scan it, and you will get more information. Thanks for listening today.